Today's topic is electric fields and static electricity. So, the idea behind static electricity is when you have protons and electrons, and it's this transfer of electrons from one material to the other. Now, there's some ways where this can happen. Main one is friction. When you have a cloth and a polythene rod, for example, polythene rods are made up of protons. The cloth is made up of electrons. Because in static electricity, like charges repel and unlike charges attract, you have the electron that goes into the polythene rod because of the presence of protons. That makes the rod negatively charged. But what that also does is that it makes the cloth positively charged. There are other ways where this can happen as well. Another one is induced charging. For instance, you have a balloon and you have a wall, for example. Let's say your balloon is made up of protons, right? Positive charges. And then you have the wall, which is made up of electrons, negative charges. If you place the balloon really close to the wall, where the electric field will allow the electrons in the wall to come up and get at least some attraction to the protons present in the balloon, the balloon will become negatively charged. That is the whole idea. But once those electrons make contact with any force on Earth, whether it's a wire or anything like that, anything that is grounded to Earth, if the electron makes contact with that, the protons will disperse throughout the rest of the wall and the electrons leave the balloon. Another thing about static electricity or field lines, the electric field lines. Electric field lines can be confused with magnetic field lines for some time because you have the like charges repel and unlike attract. But when you look at it, it's different, completely different, because in magnets you have poles and here you have charges. So let's say you're taking a diagram, right? You have the one proton here, one proton here. Field lines will go that way for both. Because of the fact that protons do not attract. If you have a proton on one side and an electron on this side, the lines will come out like this because protons and electrons attract. Another thing that's really important in static electricity is the understanding of the force. How do we measure protons and electrons? The unit is coulomb. Coulomb is a unit that you take. So with this unit in mind, with this unit in mind, you're able to derive the sense of the forces that hold the electrons and molecules together. That force is the electrical force. So when you have something like, for instance, if you have something like how I put this, explain this real quick. Well, if you have, let's say you have particles. The particles are brought together by an electric force. These particles then make molecules. Molecules are then used to make solids, which make you, because you're a solid. So let's just say without electrical force, you wouldn't be able to stand and walk. That's the importance of the force, and that's why it's considered a fundamental force, because it's a gravitational force that holds all particles together. So in summary, static electricity is pretty much the movement of charges between two objects. And that's about it for static electricity.